Heat which can be shaped to fit exactly where it is needed. Shaped heat. When electricity flows through a nickel-chrome wire, heat is produced. The wire, however, is live and needs supporting on insulators, and in this form it is difficult to apply to everyday needs. But if the coiled wire can be placed in a tube and insulated from it, then we can have the benefit of the heat produced without fear of shock. Now the coil is completely supported, the tube may be bent to any shape required. Producing heat in a tube, or a tubular sheathed heating element, is the speciality of the Backer Electric Company of Rotherham. In this modern factory, with the help of the most up-to-date techniques and machinery, next year over 8 million feet of tubing will be turned into heating elements for commerce and industry. Where do they go? Many of the domestic applications of the elements are familiar. A modern house will probably contain Backer elements in the cooker, washing machine, kettle, steak grill, coffee machine and immersion heater. Others go to industry, such as the Ford foundry, where there is unlimited scope for shaped heat. Apart from the wide range of applications, there is also the question of demand. A domestic appliance manufacturer may require 10,000 per week to keep his production lines running, whereas a machine breakdown in a foundry may call for one-off. So Backer used two processes. The powder filling process is used for bulk production when several thousand of the same design are required and produces an element with a circular cross-section. The conversion process is used for small batch requirements or even one-off orders and produces an element with a diamond, square or other non-circular cross-section. Both processes require a stock of many sizes and types of tubing for the outer sheath material. Both processes use nickel-chrome wire to form the central heater coil. Both processes require magnesium oxide to insulate the coil from the sheath. But the processes differ in the way this insulation barrier is produced. The conversion process uses magnesium tubing, which will be converted into magnesium oxide in an autoclave, whereas the powder filling process uses magnesium oxide in its pure state to form the insulation barrier. We have the raw materials. Let's start making elements. First, the heating coils are prepared. Automatic machines coil the wire to the right diameter and cut to the required length. Length and resistance are constantly checked. For powder filling, a solid rod terminal is welded to each end of the coil. This has a small latch at the free end to allow it to be hung in place on the vertical filling machines. Hoppers above the machines are filled with magnesium oxide powder. The powder flows from these hoppers down jets which are lowered between the coil and the outer sheath. The vibrating jets rise slowly, centralizing the coil as they go, filling all free spaces with oxide powder. The insulation is then consolidated by feeding the elements through reducing rolls, during which they decrease in diameter and increase in length. On On leaving the rolls, the length is checked to see that it falls within the prescribed limits. All elements are then loaded onto the moving belt of a gas atmosphere-controlled furnace for drying and annealing. And on leaving, a batch of heaters produced by the powder filling process is complete, in straight form. This is the type of element which finds its way into your home in one of these modern domestic appliances. Less obvious is the heater in your washing machine. At the Easy Clean Works, shaped heat is built into their machines. The elements are designed and supplied conveniently with all leads attached. And this type of element has an over-temperature cutout built in. Fitting takes only a matter of seconds. Another assembly line, this time at the works of Belling. Grill and oven elements are usually designed in conjunction with the manufacturer during the development of a new cooker. There is a tendency to standardize on boiling plates with other cooker manufacturers for convenience of production and servicing. Such a demand for a standard product requires a fast-moving production line capable of handling enormous quantities each week. You have seen the straight element produced. Now watch it created into the familiar spiral shape of a boiling plate. The boiling plate elements, which still have a circular section, are flattened on a 750-ton hydraulic press to provide a level working surface that will give maximum area of contact with the housewife's pan. At the same time, the fixing plate is fitted. Every element is placed on load and at full temperature is subjected to a severe high voltage test, far in excess of British standard requirements, to ensure that only perfect products reach the market. The element, while still hot, is immersed in water, and should there be the slightest flaw in the sheath material, water would be drawn into the element and would reveal itself on this mega test. Further stringent testing is applied before the elements are shipped to the cooker manufacturers in accessible, conveniently stored open crates. On the fast-moving production lines at Tricity Cookers Limited, the plates are quickly fitted with their leads, ready for assembly into the hob. Apart from over 2 million boiling plates, Tricity have fitted as many grills and oven elements to their range of best-selling cookers. It is not necessary to buy a new cooker to enjoy the advantages of fast, radiant boiling plates. Backer produce an interchangeable design available through electricity board showrooms and retailers. A leaflet gauge is provided, which, when placed over the pins of the solid plate, clearly indicates the radiant equivalent required. Simply switch off the cooker, unplug the old plate, and plug in the radiant. But not everyone wants a million. Perhaps 10, 6, or even 1 are all you will ever require. The Backer conversion process caters for just this type of need. The founder, Mr. C.B. Backer, developed this technique, which is ideal for small batch requirements. In this process, the magnesium tube, which is to be converted into the insulation, is inserted into the outer sheath, and the heating coil is drawn through the center of it, using an outsized bodkin, and secured at each end by ferrules. Hollow-end ferrules are used so that water may flow through the assembly when it is placed in the autoclave. The autoclave works in the same way as a pressure cooker. When the elements have been loaded into the vessel and the pressure head clamped down, the autoclave is filled with water and brought to the boil. At high pressure, the water gives up its oxygen, which is absorbed by the magnesium, turning it from a tube of metal to a tube of magnesium hydroxide, still holding the coil perfectly centralized. When the water is driven off, we are left with pure magnesium oxide insulation between the coil and the sheath. The element has rigid terminal posts packed into each end, designed to take a variety of terminals at a later stage. The element, which now looks very similar to the powder-filled element in its straight form, is further improved by being compacted between dies. This gives it a quicker heat response, better test qualities, and a non-circular section, except for the extreme ends, which are left round to take fixing plates and other standard mountings. Sometimes a square section is provided, which is ideal for groove embedding in platens or dies. The element, being complete in its straight form, is now passed to the bending section, where elements from both processes meet. Bulk quantities are quickly formed to shape on specially designed powered machines, but hand bending is still found to be an efficient method for small quantities. Yes, even this means work for Backer. There's always a large demand for kettle elements, and Backer have been able to meet this by producing powered jigs and press tools to speed the flow with minimum effort. Stage by stage, the elements take shape until they're ready for brazing into the kettle head on automatic machines. After bright chrome plating, each one is pressure tested to ensure there are no leaks and electronically tested before assembly of the cutout. Backer were the first to fit a snap-action tri-metal cutout switch as a built-in protection to safeguard the element should the kettle accidentally be switched on dry. The cutouts are soldered in position, but not on the terminals, as on earlier designs. All elements have the new 3-pin terminal assembly, which is used on the latest models of kettle. To kettle manufacturers, the elements are supplied in open crates of 100 for convenience of storage and accessibility on the kettle assembly line. When these elements are supplied to the wholesale and retail trades, they are individually packed in an attractive polythene display bag, which is then packed in cartons of 10. As the standard replacement of a 2-pin element, Backer offer the conversion kit, comprising element and washers, connector shroud and connector. But if the customer already has one of the new 3-pin connectors, a standard pack comprising element and washers only is required. More specialized work is carried out in the new industrial department, leaving the main factory clear for bulk orders. Industrial applications of tubular sheathed heating elements sometimes require most elaborate shapes to put the right amount of heat in the right place. Experienced operators deftly bend the elements into the intricate shapes required and fit them to the platens or molds supplied by the customer. Often, elements are tailored to fit a part of the customer's apparatus. After bending, terminal boxes, head mountings, fixing plates, leads or terminals are brazed or clinched into position. At the works of Gallencamp in London, elements are assembled into various types of laboratory and hospital equipment. This type of apparatus requires a great degree of accuracy and reliability. Here is another application where the element is cast into an aluminium hot plate used for boiling flasks in laboratories. By contrast, an aluminium extrusion press container is reconditioned by fitting an improved design of cartridge element around the container body. Similar but larger cartridge heaters are being fitted to this mammoth aluminium extrusion press at the works of Fielding and Platt in Gloucester. The Backer site installation team deliver to the customer's works and assemble the heaters in position around the container before interconnecting them with high-temperature buzz bars and testing. This plant has been exported to Australia. Power station bolt heaters are used for expansion tightening of turbine and condenser bolts. Sometimes a number of elements are assembled as complete units. This is an industrial space heater nearing completion. The finished product is now given its last and most careful inspection. Every element is checked against the drawing for dimensional accuracy or test assembled in part of the apparatus. It is then subject to resistance checks, flash and mega tests. Not only our own, but visiting inspectors are provided with every facility to check over their contracts, and they make final tests using the most up-to-date testing equipment. The elements are now ready for delivery to the customer and are packed for dispatch. Packing is not only protection, but presentation. Backer encourage customers to show and sell rather than buy and stock. The Backer house colour is carried through both boiling plates and kettle element cartons, and a clear indication of contents is visible at all times on the shelf. For convenience of stock taking, products are cartoned in quantities of 10. Export orders are received from all over the world, and there are many familiar names among the companies supplied at home. The Ford Motor Company has several thousand Backer elements in use, primarily for heating the dies used on shell molding equipment. This process, which is dispensed with traditional sand molding techniques, produces shell molds and cores of formaldehyde powder, which, when blown into contact with the heated, shaped body, cures into a biscuit form of the required shape. This is a quite different application. Hondens of Hyde near Manchester design and manufacture machines which produce plastic bags and sacks of infinite variety. Backer elements are fitted to the back of the guillotine blade, which both seals the end and parts the bag from the roll. This is a smaller machine, producing at the rate of over 200 per minute. The two processes you have seen are planned and coordinated to produce each year over 8 million feet of heating elements. The flexibility of having two processes allows the customer to have the best of both worlds. As a bulk user, he can be regularly supplied with powder-filled elements in the quantities required to keep production lines moving, while just as much care and attention is given to the converted element program, which deals with the batch requirements of specialized manufacturers. Becker heating elements are the vital hidden heat source within so many home appliances. As you travel the world, they keep you warm on trains, heat your food on planes, and help the chef to cook the meals for passengers and crew on ships, be they liners or tankers. A truly universal heat, made to measure, shaped to perfection. Shaped heat.